Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies, and welcome to this latest episode of Dan's Vehicle Dynamics Corner. What I'd like to talk to you about in this episode of Dan's Vehicle Dynamics Corner is why you are mad not to use simulation. Before I get into the nitty-gritty of this tutorial, I'd like to take a moment just to discuss the motivations behind this tutorial and where it's coming from. Over the past couple of years, whether it's been in Dan's Vehicle Dynamics Corner or the various ChassisSim tutorials that I've given you, I've focused on the nitty-gritty on how to use ChassisSim. I've also focused in Dan's Vehicle Dynamics Corner on the more general aspects of race car vehicle dynamics, for example, force-based roll centers. I've also gone into the fine points of vehicle dynamics, such as what are modern approaches to tire testing and where they come from. But one of the things that still continues to astound me is why simulation is still not widely used. And quite frankly, I say this right now that as far as I'm concerned, if you're not using something like ChassisSim in your day-to-day race engineering operations, and I don't care whether it's a Formula 3 car, a Formula SAE car, a GP2 car, or even something like a Clubman car, as far as I'm concerned, I think you're absolutely crazy. And the reason I think you're absolutely crazy is I just don't say it because I have a vested interest in everybody using this so I can make a hell of a lot of money. The reason I say that you are not why you are crazy not to use simulation is the fact that I have seen firsthand in multiple formulas how the use of ChassisSim has transformed race teams and has gotten absolutely undeniable, clear, concrete results. And really, this is what I want to touch upon in this tutorial is why, if you're thinking about running a race team or any race engineering operation whatsoever, a race car simulator must be an indispensable part of the toolbox that you're using. Bottom line, ladies and gentlemen, if you want to win, you need to know why. There are no shortcuts around this. I could make an awful lot of money by telling you I had the latest magic tweak that I could give to you, that if you just plug in a few numbers, hit the go baby go button, you're going to be half a second to 2 seconds quicker than the rest of the field. Well, quite frankly, ladies and gentlemen, if you're encountering people like that, as far as I'm concerned, they should be locked up for their own safety. I can tell you right now, I've had the privilege of working with some of the best race teams in this business, and the common threads are, if you are serious about winning, you've got to know why. There are no ifs, ands, or buts about this. And if you take a look at the attributes of the people who are successful, here's the thing. They know their basics inside out, they take nothing for granted, and they are always looking for that next edge. And this, ladies and gentlemen, is the reason why simulation is such a powerful tool, because it tells you the why. And as far as I'm concerned, it's a completely and utterly indispensable tool for really getting your head around the race car. What you get out of simulation, it will force you to understand your car in ways you never thought possible, and that is a theme that I have seen emerge in countless categories across the ChassisSim community. And let's face it, the ChassisSim community now covers a very, very broad brushstroke of the motorsport community. Everything from Formula SAE to Formula 3, GP2, sports cars, touring cars, sports cars, etc., etc. It's been a it's now an extremely wide spectrum. And I'm not just talking about this as an abstract idea. I've seen this happen firsthand on more countless formulas than I care to mention. Now, the other thing that you're going to get out of simulation is it's going to help you understand the key components of the car. It will give you valuable insight into the tires, and it will allow you to quantify your aero without being dependent on, well, somebody said it just did this. It also gives you the opportunity to conduct small and sensible what ifs. I cannot stress that point strongly enough. And as far as I'm concerned, ladies and gentlemen, those combination, those three factors I just mentioned for you, is why a simulation that you've developed yourself completely in-house is absolutely indispensable. It will transform the way you engineer a race car. As I've touched upon before, if you are serious, you've got to do the modeling yourself. There are no ifs, ands, or buts about this. The simulation results that you get are the full stop at the end of the process. When you do the modeling yourself, you'll be amazed at what you learn. And I'm just not saying that as a sales pitch. I am saying it because I have seen it happen in countless formulas I've been involved with. And I don't care whether it's been sports cars, open wheelers, touring cars. The amount of times I've had colleagues in the ChassisSim community say to me, wow, I really didn't know that it was actually doing that. Let's put it this way, if I had $5 for every time I'd heard that, I would not be giving this tutorial today. I would be retired in a subtropical paradise. And here's the thing, it forces you to think about what the car is doing. So as far as I'm concerned, this is why simulations that you have developed yourself are so powerful. And I'll also say that from a simulation vendor's perspective, yes, I certainly have considered the plug-and-play simulations, and as a corporate reality, I certainly wouldn't rule it out. But as far as I'm concerned, if you're serious about it and you're serious about getting the value for this, you've got to do it yourself. Now, I realize that one of the most insipid things that's happening in our society is the fact that the whole plug and play thing, that you just plug in a few numbers, you hit the go baby go button. Yeah, that might be okay to get you going, but quite frankly, there are no shortcuts in life, ladies and gentlemen. And quite frankly, if you hear someone who's offering you consistent shortcuts, here's a tip: they're trying to sell you something that fundamentally won't do the job. The other thing I just want to touch upon before getting into the wheres and whats and why of why you're crazy not to use simulation data, is one of the core pillars of ChassisSim is that the Tyre models are created by comparing actual to real data, and we change the Tyre model to minimize the error between actual and simulated G. This is, I can't speak for other simulation packages, but this is one of the jewels in the crown with ChassisSim, which is why we can get such stunning correlation. And indeed, it's one of the aces in the holes that you get with ChassisSim because of its ability to look at data and back out the Tyre model from there. Getting on to forcing you to understand the car, tyres. One of the key things about simulation is that ability to quantify tyre behaviour, as we just touched upon before. And this is an example of a traction circle radius versus tyre curve that was actually backed out for an open wheeler race car. For this particular formula, it was one of the secrets for unlocking what was actually going on with this particular motor vehicle. So as far as I'm concerned, if you don't have the ability to look at something like this, as far as I'm concerned, you're absolutely and utterly flying blind. The other thing that it forces you to do is it basically forces you to understand the aero. Let's have a look at this particular example where I've got a comparison of actual versus simulated pitch. The data is colored, the simulated is black. Now, as you can see, the front pitch isn't too bad, but you can see the rear pitch, there's a pretty big discrepancy there by about 5 or 10 mil. When you're seeing something like that, you're seeing a massive hole in the aero map. Now, a lot of people would look at that and say the simulation's rubbish. Well, I can tell you right now, the simulation isn't rubbish. What's happening here is the simulator is telling you there's something in the aero map that isn't matching up. And part of your job as race and data engineers and as vehicle performance engineers is to identify where those holes are and nail down. And I can tell you right now, from seeing this in actual data, these are the things, ladies and gentlemen, that win races. So you absolutely and utterly ignore this at your peril, because I've seen God knows how many countless formulas where people have used ChassisSim to quantify what's going in the aero map, and they rock in on race day and they make their competition look like complete fools. So you ignore something like this at your peril. I should also add that the other thing that simulation forces you to do is it really forces you to get on top of things like your pickup points, your suspension geometry, your motion ratio. So that in and of itself is an absolutely invaluable exercise. Also, too, everything in ChassisSim is done transiently. Consider this plot of load variation through the corner. As we can see here, we've got, this is speed, neutral steer and steer, throttle, and tire load. Take a look at what's happening with our tire loads going through this particular corner. The tire loads are banging around, etc., etc., etc. This is one of the other keys of why ChassisSim can achieve such amazing correlation without being overly reliant on grip factors, because of the fact that you can take into account this transient behavior, and that gives you such incredibly valuable insights to what's going on in the car. And going on about what we've just touched upon, it once again, it gives you a real window into the soul of your race car. The other thing too that I want us to touch upon is that when you're using simulations, you use it for small, sensible changes. A simulator is a scalpel, it's not an axe. And I think if there's one point that I can really touch upon of where a lot of people have lost the plot with simulation is where they use simulation to make huge global changes. For example, if you're running a car, say, with 800-pound rear springs, and you've done your modeling around 800-pound rear springs, all of a sudden they expect, okay, let's whack in a 100-pound rear spring and see what it does. Well, here's one small problem. All of a sudden, that is a massive change to the vehicle model, and all of a sudden you've set the vehicle model up, say, around an 800-pound rear spring. All of a sudden you've taken it to a 100-pound rear spring. You've taken it out of the zone you've just modeled into a totally different area, so consequently you're just guessing. So consequently, when you're using the simulator, use it like a scalpel. You're doing it with small, sensible changes around those setup variables that you those setup variables that you play with. Now, what we see here is that we see that we've basically got our variance is varying very, very slowly. That's an example of a very, very good change. And where you know the simulator's throwing you a furphy is when you see a big change. So, what variables do you use the simulation for? Well, you use it for an awful lot of variables. A really good case that I've illustrated here is to really refine how to basically refine your ride height and bump rubber packages. Here we've got basically our front pitch, our rear pitch. We've got our front ride height, our rear ride height, and we basically can look at what our bump rubber displacement is doing, so we can really nail down about where we want our bump rubbers to engage, where we want them to go in. And also, too, the other effect that you'll see if you're making small sensible changes, you can see really good subtle impacts on what the car is doing. Now, let me just say that with regards to the variables that you'll be looking at, you don't necessarily aren't going to see massive changes in steering and throttle application. What you will see is you will see changes in speed, and that's the thing that you're actually that's the thing that you're actually using for. And I can tell you right now, from countless stories I've seen in the ChassisSim community, both doing it myself and seeing my colleagues doing it, the advantage that this gives to members of the ChassisSim community is by the time they climb that pit wall for that first session, they're already prepared. They know what their program is. They're not guessing. So consequently, they're so much more prepared what to actually work for, which makes their track time so much more valuable. Does simulation replace track time? No, it doesn't. And anyone who claims that simulation does replace track time is a damn fool. However, what it does do is it used in concert with track time. Your simulation package is your very, very best friend. So to sum up, the reason why you're mad not to use simulation, if you're serious about winning, you've got to know why. And simulation is perfectly positioned to help you do this. And the unique thing about ChassisSim is it's based on a transient model that uses real data to fill in the blanks. Also, too, if you're serious about getting the most out of it, you do the modeling yourself. And if you use it this way, not only will the results come, you will find that simulation will be an indispensable tool that you can't do without. However, don't take my word for it. If you're not a member of the ChassisSim community, by all means, sign up for the online simulation, try it for yourself, and see just what a valuable tool ChassisSim can be.